All right, we're going to talk some impulse momentum practice. So we are going to try and figure out how satellites work in outer space. So here's a scenario. Satellite's orbiting the Earth at 3,000 meters per second. It needs to reduce its speed to 2,000 meters per second. I'm sure they're going to spy on someone with this satellite. To do this, it uses some thrusters that apply a constant force of 10,000 newtons. How long should the satellite turn on its thrusters for so it can change its velocity? So you got to figure out time. All right, that's our goal here. Solve for time. How long should these thrusters be on to make this work? So draw your pictures, list your givens, whatever you got to do, go for it. I'll be back with the answer. All right, if you're still here, then I'm going to guess you're curious what the answer is. So the answer is a whopping, what'd I get? 50 seconds. All right, 50 seconds. That's what I got for my time. So how did I get that? Well, if you want, you could draw a picture. There's no problem with that. Draw a picture. Basically, you're just going to have a satellite in outer space, and it's moving this way, and the force from the thrusters is going to work against that motion to try and slow it down. So if I list all the things I know from this problem, there's actually a lot of information in this problem, and we're just going to list it out, and we're going to see what we can do with it. So behind door number 1 is all my info, which I'm sure you listed out. It talks about the initial velocity being 3,000, the final velocity being 2,000. It's got a force of 10,000, which is, like I said, if you want to get super nitty-gritty, basically you're saying it's going in the negative direction. And, well, actually, I'll bring that up later. You should say it's in the negative direction. And so your mass is 500 kilograms, and your change in time is what you're looking for. So since this is clearly an impulse momentum problem, I mean, you've got change in velocity, you've got force, time, the whole 9 yards, then I'm going to bust out my big dog conservation of momentum equation that's behind door number 2. I'm sure you listed this out, as we've talked about from class and things like that. The big scary. So let's just talk about this for recap. This here is my impulse. Force times change of time is how you calculate impulse. And then mass times change in velocity is what happens to an object when you apply an impulse, because it fundamentally ends up changing its momentum. So from this long set of equal signs, the only two we really need is this F delta T and the M delta V. So we're going to focus on those two. We're going to pull them out. Depending on the problem you run into in the future, you might say focus on delta P and just impulse. Okay, you can pull whatever you want. This equals that. They're all equal to each other. So we're going to pull that out, and we're going to substitute in all these variables where they belong, and we're going to kind of crunch the numbers here. It's kind of one of those straightforward plug and chug type problems once you see what it's actually all about. So here we go. The force, you see I put my negative sign in there because the force, as we drew it, is going to go against the motion. So if my velocities are called positives, then my force should be negative. So I should have put a negative over here. I caught myself when I did my math over here. So for change of time is what we're looking for. The mass is 500. Here's my change in velocity. Remember, it's always final minus initial. That's your change. And so when you do this, you get a negative on the right-hand side. And since you can't go back in time, unless you're Marty McFly and have a flux capacitor in hand, you have to have a negative on this side of the equation. So that's how it kind of reinforces the fact that you have to have a negative force if you're going to have a negative change in your velocity. So you do the math, you get 50 seconds. And that's pretty much how you solve it. So really, all these impulse momentum problems are really your ability to use and manipulate this big equation. Pull out what are the key things to relate to each other and write the equation and solve from that. So hopefully that helped, and I'll see you next time.